So we need some help. So what we're going to do is we're going to use a table that I've got copies of. All the answers are in this chart. We just have to know how to read it. So let me set up a couple things. Before we get to that weirdness, can anyone tell me, this shouldn't be that evil, what percentage is down there? Is everybody cool with that? That's 2.5% for sure. Because that was 95%, so that's 5%, so that's 2.5%. Because the mean cuts it in half. It's symmetric. Boogie woogie. Now, let's take a step up from there. Can somebody tell me what percentage? Well, let's see. Can you guys figure out what percentage is here? How'd you figure that out?
Well, because it's 34 and 34, but then if you add on to the other both sides have to be 50.
13.5.
Oh, 13.5. Sorry.
You got close. That's why I was curious how you got there. Look at these guys competing. That was a tie. Sorry. All right, everybody else, let's catch up to what the shit's going on. There's 68%, and there's a lot of different ways to do this. There's 68% there, right? There's 95% there. So what percentage is on both sides? It would be the amount that's outside of here. That's one way to do this. It'd be 95 minus 68 is in both of these, right? That's one way to do this. 95 minus 68 is 27. And then, of course, if I just want that side, I would have to cut that in half. There's 13.5. That's not the only way to do that. And we're actually not going to do that anyway, so listen. We could if we needed to, but now, that quickly becomes useless. Because does every z-score in the universe become a nice whole number like this? Integer? No. Somebody's height could definitely be 1.17 z-score. And I'm like, what's the probability somebody's taller than that? I can't figure out this area from this shit that I know. I only know a little bit. So that's what the chart does for us, right? It's this thing on crack. It just fills in all those things in the middle. So I can get much more precise. So let me give this to you. We're going to recapture some of these numbers from it so we trust it, and then we're going to do some more problems with it. Oh, I forgot to say this in my other class. Damn it. You're going to be using these on tests and quizzes and stuff, so do not write on these. Maybe put your name on there or something, but don't write notes on here or something, because you're going to turn it in with your stuff. You got notes in there, you're going to lose points. Shit. Okay, so don't do that. Shit. Here. All right, so this is a little bit funkadelic when you first get it as for how to read it, but they did a great job of figuring out how to shove all the shit on the one, two sides of one piece of paper. It's crazy. So now watch this. If I wanted to double check this, the way I would do that, I have a negative z-score here, right? If I want to double check this red area, we got 2.5%. So that's negative 2.00. I want to be really precise, because how do you read this chart? These are the first decimal place, and then these are the second decimal place. So negative 2.00. You You see that? And so we get 0.0228. So that's much more precise than this kind of like hand wavy 2.5%. Okay, so let's do another one. Can somebody tell me what this area here would be? Above 1. From here. Don't worry. So this 68%, right? So what percent's outside? 32, so what's on that side? 16%. So let's see what we get in the chart. Now we gotta be careful. What does this chart always tell you when you look up a z-score? It always tells you the area below the z-score you just looked up, right? The area to the left. You with me? So if you look up 1.00, you're not going to get the right answer yet. So what do we get when we look up 1.00? 0.8413. So where's that? Let me redraw this picture. Where is that on the picture? Where's 0.8413? Down here. You guys see that? So the chart only understands or gives you areas that are below what you look up.
Because we just subtract that from 1.
Beautiful. So the other side has to be 1 minus that. Of course, if I know one chunk of a picture, the whole picture, of course, makes 1. So what's this side got to be? 1587. I like it. How you guys doing? You guys all right? I can never read you. Now is a great time for questions because we're going to use the shit out of this chart for a decent chunk of this class. So again, how did I get that? If you look up 1.00, 1.00, does everybody see how I got 8413? And again, now, please just think about it. That's 84%. Would it make sense that that's 84% of the picture? So visually, I know it's got to be over there, and I know the chart only ever tells me areas below what I just looked up. That's how it's built. But what was I asking for? I wanted this probability. I want that area. Yes? Maybe? Everybody's cool with the 0.8413. Let me just triple check here. Everybody's cool with that. Then the only thing extra I'm saying is that's the wrong side. I want the other side, right? Didn't I want this area up here? From the beginning, that was the question. I wanted that area, right? Did you find that area yet? No. So if that's 84.13%, the other side must be the rest. 1 minus that. That's all. Yes, that's it. Neutral. I love it. Maybe? No? If this board is 9 feet long and I cut off 7.2 feet of it, what's that? Yes. So what's this whole picture is 1, right? It's a visualization of a probability distribution. Therefore, the whole area has to be 1. So if the whole area is 1, the whole area is 1, and this is 0.8413, that must be 1 minus 0.8413. Of course, that's all. There's that 1 minus thing again. I got the opposite of what I want, so 1 minus that is what I want. Okay, maybe. All right, so let's do this. Let's do something a little, and then I'll actually show you what's happening up here. You probably want to know that. Did I get any erasers in here? There. There we go. I smooshed them. So let's do something a little more interesting. So when I'm doing this, when I'm making this picture, these are z-scores, right? Because the middle is 0 and 1 step away. So these are z-scores right now. In fact, that's what this chart is the z-score chart. So you have to have z-scores to be able to use this chart. So what if I said, what's the probability that z is less than 2.08. So draw that picture first. What really drives me a little insane is people seem to put the 2.08 wherever they feel like doing it sometimes. Where's that 2.08 got to be? Can it be here? No. Right? It's got to be over here somewhere. And then what's the area that this is asking for? Where would you shade? Less than, which means below, to the left. So I want that area. You already know the answer is going to be bigger than 50%. You with me? I love you guys, because the mean cuts it in half, and that's going to be that's going to be bigger than 50%. So the picture should help you make sure the answer makes sense. So what I'm looking at, watch this. If somebody here was tall enough to have a z-score of 2.08 for their height, I want to know what percentage of people would be shorter than that. What percentage is that person taller than? That's kind of like what this question would be related to. So what do you guys get when you look up 2.08? So positive side. 2.0. Yeah. 2.08. Does everybody see how this reads? 2.0. 2.08. There it is. So I go right there. 9812. How you guys doing? You guys see how to read this? It's not difficult. It's just different. 2.08. So 98.12%. That makes sense. That makes physical sense. Should be a decent chunk of the data. Okay. Maybe. And I forgot to show you. I'll do it on the next one. So what if I had a normal curve and I want to know the probability that z is greater than negative 0.16? Try to draw the picture and then look it up. Greater than negative 0.16. I want to point out a couple things as I do this. Is everybody cool with that? I know it's normal. I know I have z-scores, so the middle is 0. Put negative 0.16 in the correct place. It's a regular old real number line. Looking at the picture, I know the answer is going to be a little bit more than 50% again, right? Just a little bit more this time, because it's not very far away from 0 there. So always put z-scores down here. Up here, you immediately put the area you find below it, because that's what the hell the chart tells you. And just to really close the loop here, the chart tells me areas that I certainly, I could never calculate the area of that shape using regular old geometry. There's no way in hell. So that's what the chart does for me instead. It says, okay, I got you. I just have to know where to look to get the answers. What do you guys get for that side? Let me show you guys this time. Come over here. Everybody cooperate. All right. So I got to look on the negative side. Negative 0.16. So I get 4364? Yes? You guys with me? Everybody good with that? Okay. 4364. Is that my answer? No, because I was nice to myself and actually shaded the answer. So the picture should help you. So what's the actual answer then? 5636. I like it. You guys look up look at positive 0.16 real quick. Just to be crazy. What do you guys see there? Something interesting. What the shit? What the deuce? So positive 0.16. I got the answer. How the hell? Well, the area that is above negative 0.16 has to be equal to the area below positive 0.16 because of symmetry. That's a shortcut. That's a shortcut. Do we have to use it? No, it wasn't that hard to get there. But just in case you want to use it, you can. It saves you like a second and a half, but still. Maybe. So I really want you guys to understand, this is exactly the same kind of problem that we did when we had the big ass rectangle for uniform distributions. The step that I need help with is calculating the areas, and that's what that does for us. Nothing else is really different, to be honest. Okay, so let's try another one. Let's get a little bit funkier here. Step up the funk. Scheisse, I gotta readjust you. Rawr. It's so hard, Jeff. Shut up. All right. So here, I'm just gonna put this up there, and you guys think about it. So given a normal curve, there's a probability that I get this. Try to draw it. Try to figure out how the hell to do that. You get better markers. You write it again. Is this better? All my markers are dying. Tie him to a string and swing him around. Should be able to draw it. What's a quick way to say this? The Z's are between. I love it. So it's going to be a sandwich. I'm going to put the jelly in there. So then we want this area here. The chart cannot handle that area directly. It don't know that area worth shit. It only knows areas below. So look up 2.43 for me. Let's get that area just to get something. What do you get when you look up 2.43? Do it again. 9925? Yes? Is that too little or too much area for what I want? Too much, right? It doesn't stop where it's supposed to stop. I want it to stop here. So how much area do I have to cut off of this? Whatever the hell that is, right? So if I look up both z-scores, get the areas, I subtract them to get what's in the middle. That makes physical sense. So what do you get when you look up negative 1.81? Yeah, negative 1.81. Now watch this. This really sucks. Just to point this out, this is a beautiful example. This is not negative 1.81 here, right? Because that's 0. Ah, shit. It's really easy. So negative 1.801. There's negative 1.81 there. So 0.0351. So that is too much area. I want to subtract off that much area so I can get just what's in the middle. So just subtract those two areas. Yes, please. What do you mean? How do you mean? Do you mean using the normal?
Yeah.
No. Too bad. If you know that, you can use it to check your work, but I need to see this shit because I'm crazy. Learning doesn't happen when you push buttons. I will eventually show the whole class that shortcut, but not now. So yeah, what do you guys get when you subtract those two? 9574?
Yes.
Ish. Okay. Maybe. Okay. One more of these, and then I want to do the next level. So let's see. Let's say this is 3. So this is 4. What's the probability that I get z greater than negative 3.81? This one has some weirdness happening on the chart. Let's see if you guys can interpret it. I know the glare sucks. Oh, I got something. I forgot to bring my paper with me. Let me move up here for you guys. So I want the probability that z is greater than negative 3.81. Come here. There you go. Should this probably be big or small?
How big?
Yeah, it should be almost 100%, right? But what do you get when you try to find this on the chart? Yeah, negative 3.81, it says negative 350 and lower is 0.0001, right? And where is that on the picture? Where'd I put 0.0001? Down here. It always tells me the area below. So then the answer would be 1 minus that. Yes. So are you cool with, if you try to look up negative 3.81, it doesn't go that far. It says negative 350 and lower, use this, which I disagree with, and I'll talk about it in a minute. But it's on the chart, you can use it. 0.0001 is below what I just looked up. So what's above it? 0.9999. I would say this is about 0% and this is about 100%. Because especially once you get to like a z-score of 7, 8, 9, screw this shit. This is more like 0.000000032 or something. It's like, good lord, that's basically 0%. It's like that 0 plus on that chart we looked at the other day. But either way, since it's on the chart I gave you, it'd be really mean if I didn't accept that as an answer. So I'll accept either way. Maybe? Okay, so here's the next level. If I don't have z-scores to work with, I have to convert them into z-scores. And just to tell you right now, I'm going to tell you this a few times. Because I don't think I haven't. There's a question that will be on test 2, it'll be on test 3, it'll be on the final exam. And I'm going to tell you the answer. And I'm just hoping for the day that more than half the class gets it right. And I want to let that sink in. Everyone's like, just tell me what's on the test. And when I do, I don't quite get half the class get it right. What does the z-score tell you? All right. The number of standard deviations from the mean to the data point. That's it. So z-score tells you the number of standard deviations from the mean to a data point. So it is a measurement of distance in statistics. But if I ask you what it is, don't just say distance. Be specific. Everybody get that? I don't care how you say that, as long as you capture that idea. Z-score is the number of standard deviations from the mean to a data point. And that's why the formula for z-score is how far is the data point from the mean, and then a divide to see how many standard deviations fit in that distance. Okay, maybe. So if I don't have a z-score, I have a way to make it into a z-score. Just to make sure, let me give you a problem. There's going to be a reason I can't do this problem until I say one more thing. So if I said the mean of something is 12 and the standard deviation is 1.95, and I say find the probability that x is greater than 13. You cannot do that yet. I have not given you enough information to do it yet. What's the only time I can use this chart? If I have a... No, I know you need a z-score, but it's got to be a normal distribution. It's got a picture on it. So if I don't say it's normally distributed, you actually can't do shit. Right? So if you think you're in a situation where you can't do anything, still do it. Because more than likely you're wrong. You missed something. Later this semester, there will be... I really want this. This is a collection of answers. You guys understand that now? We found the answers on you. This is a collection of answers. Just sitting here saying, just find the answer. You're done. You just have to know how to use it and when to use it. So a huge chunk of statistics is all about when can we tell something is normally distributed enough so that I can use this. Because if I can use this, I got all the answers. So there are several situations where we can check to see if something is normal enough. If it isn't, shit, we can't do it in Stats 1. We can maybe do it in Stats 2, but we don't even teach Stats 2 here. But if it is, hey, I got all the answers. I just have to know where to look. Maybe. Okay. So let me add this piece of information. It's a normal distribution. Now we can do some shit. So why don't I just look up 13 on the z-score chart? Because of course 13 is it a z-score? Nope. It's what we call, this is officially called a raw score. Because it hasn't been processed yet. I haven't changed it into a z-score yet. But can you guys draw the picture just on what I've told you? What goes in the middle now? They're not z-score, so it doesn't have to be 0. What's in the middle? 12, because that's the mean. And I'm curious about 13, right? So let's put 13 in there in the right place. And then I want the area up from there. I like it, so I'm going to shade this way. Now watch what I'm going to do. Watch what I can do. I'm going to put underneath 12, I'm going to put a 0. And that, of course, means what? That's the z-score. So what I want you to do is figure out what goes there for 13. Change 13 into a z-score.
1.
Huh?
1.
What?
1.
Not 1, no. Because what's the standard deviation? 1.95. Shit. So there's the z-score formula, right? You got to know, okay, how far is 13 from 12? And then I want to see how many of these fit in there. So it's not going to be a full step. It's going to be right around a half a step. And how many decimals do you think we round this to? You can do it. You can figure it out. How far does this go? I love you guys. Z-scores on this only goes to the second place. Right? So we're going to round z-scores to 2 places because that's all the chart can handle. I love it. So I'm sorry, do it again, 0.5? 0.51? Is that what you guys?
Yeah.
All right. It's always exciting to crowdsource a problem. So over here, I could put 0.51 underneath. Do you guys see how that makes sense? Isn't the step size almost 2? So how many steps to get from 12 to 13? About a half. So that's exactly what we got, about a half. That's what that physically means. So now I look at it like the problems we were just doing. Look up 0.51, get the area. That's not quite the right area yet. You have to get the other side. So go ahead and do that if you haven't done that yet. Water. Oh, let's see. So look up 0.51. I get this, 6950. So that's over here. And it makes sense because that should be more than half that way. No, Jeff. There you go, buddy. So what's this going to be?
0.365.
Kick ass. 30.5% chance that I find a data point above 13 in this data set. Maybe. What was I going to say? I was going to say something. It'll come back to me. Here, let me give you this problem. So we got what they went from there. Yes. Which one?
30.5. Yeah, that one.
You got 0.695 here, right?
Correct.
So to get the other side, it's just 1 minus this. Right? If that's one chunk, 1 minus is the other chunk, and it's the other chunk I want. I like it. That's why if you draw the picture, some people will not draw this picture. Those are the people that will make silly mistakes. Some people won't draw the picture correctly, and I don't know what to do. So let's say I have a different situation. Let's say I have a situation where the mean is 1298.11. Good Lord, Jeff. And the standard deviation is, what do you got, man? Let's do 148.007. Ha. Let's say this is, yeah, sure. This is rent in a certain area. Like where I used to live, in a certain area where it was cheap rent. It sucks that 1,300 is cheap. But the trade-off is you're just happy to survive day to day. So I understand that. I lived in an area. So let's say that's the situation. The average